Very
Yeah.
good. It's
Yeah.
nice that. Are we back?
Oh yeah, I don't know what happened. But yeah, we're back.
Oh wait, is it live again?
Yeah.
Yay, we're back. Okay. Hi,
Um,
welcome to Philosophising. I'm Ruby.
I'm Nathan. And Nadir
And
is still not here, I guess.
hence the technical difficulties. Um, it's okay. We're gonna get the hang of it. Um, I thought we would talk about space today. it's a it's a um it's a topic that usually gets a lot of interest from our audience. Even
Specifically
though
when we talk about aliens, I think.
I know specifically about aliens, I don't have an alien story today.
Oh, actually, I have an alien story that
You
we
have an
can talk
alien
about.
story today?
Yeah,
Okay.
yeah,
So we can't talk about aliens again.
yeah.
Um yeah, as usual, puts things in the chat. Happy to interact. I guess the big disclaimer is neither of us are astrophysicists. So we have a limited like scope of knowledge when it comes to space.
Mhm.
but we're I think we're very interested in
Yeah,
space related
exactly.
science.
Yeah.
So it's okay.
Like I think the idea was that we were just going to talk about some interesting space related things that happened or are happening soon because I guess there's a lot of them.
Yeah.
Including okay, so I was the alien story that I had was I was actually talking with so there's this group at the Harvard Center for Astrophysics called the Galileo Project, and they are interested in like trying to do scientific studies of UFOs. And anyway, I was talking with them, and they're doing some super interesting projects. Like one is um, they essentially built this array which is on the roof of the Harvard Center for Astrophysics, and it has kind of a wide field camera that tries to detect anything moving unusually, and then when they do, they then have a bunch of kind of directional sensors they can point at it. So like a telephoto camera, some sound recording stuff, some directional some radar systems, some kind of magnetic field sensors. And so the idea is to try and detect UFOs and then kind of get a better sense of what they actually are. They just collect a bunch of data on them.
I like that it uses like cameras that are already positioned to do other things.
Oh,
Like
I mean, it doesn't. It's like, I
oh, it
mean,
doesn't?
no, so that's one. The reason I was talking with them was actually I was pitching a project that was related to that. But this is a custom system that they built, which is like it's very high end, like very high resolution specialized cameras.
Ah.
And kind of the advantage of that is like they have one camera that can basically image the entire sky at once and just detect anything that seems to be moving unusually. And then they have like other stuff that can then point at it and get like higher resolution images of that spot. Um,
Oh, that's so cool.
yeah. Anyway,
That is really
that
cool.
was like
The
you're like
alien.
we don't have any alien stories, and I'm like actually we do. Yeah.
But speaking of staring at the sky, I wanted to talk about the eclipse coming up. So there's an eclipse coming up this Saturday on the 14th of October. And it's gonna happen around noon. And it's called a annular eclipse, which basically means the moon is a little bit too far from Earth to like completely obscure the sun, but it will go over the center of it. So then during the total eclipse portion, it will actually be like a donut eclipse, so where you have like a moon in the center where it's dark, and then you get this like corona that goes around it, so it'll be like a ring of fire.
Mhm.
So that's this weekend.
So
um
so an annular is the same as a ring of fire eclipse.
Correct. Our
Yeah.
donut hole eclipse, which is happening this Saturday. And my activity for today was to build a projector, like out of
Nice.
like one of these Pringles cans. I figured I would be like fiddle. If you see me fiddling around, that's what I'm doing. It's a very simple projector. You could also just find anything with a bunch of holes on it and just look at the shadows
Yeah.
around noon this Saturday.
I think like yeah, so before we started, Ruby was like, "Oh, are you gonna build a camera to look at the eclipse?" And I was like, "No, I forgot." And then she was just like, and then she was just like, "Well, you can use like a colander or something." And I guess you're gonna talk about the principle more, but basically it's very dangerous to look at an eclipse with your eyes just directly because you're just looking at the sun. It's still very bright, but you can make this camera that projects an image of the sun onto something else and makes it a lot safer.
Yeah. Actually, so I feel like one of the questions people have whenever we talk about eclipses, like, what happens when the animals see it? And I was just like, yeah,
Mhm.
animals freak out too. But I think the animals that freak out the most are probably humans.
Uh-huh.
Like humans freak out the most. I don't know if you've like gone on YouTube and watched videos of people seeing the eclipse, like 2017 eclipse. There was a full one that came over the states. Like people like drove to like Tennessee and saw it, and like people were freaking out like the first couple seconds when it like of the total eclipse part. People were just like screaming their heads off like, oh my god, the world is ending. And I was just like, yeah, we give like llamas and like whales crap for like staring at it for a little bit, and like here we are screaming that it's the end of the
Yeah.
world.
Yeah, no, my friends like during the 2017 eclipse, like people were pointing out to me, they're like, oh, a weird thing about eclipses is that it makes birds act really weird and freak out, which is actually true. But then like you're saying, like especially when you look historically, like it also makes humans freak out and act weird.
Yeah, like we are the extra freak outers.
Uh-huh.
Oh,
Like the
but there's a cool
birds just
bird
like
one.
start chirping. Humans are like, we need to end this eclipse by going and eating a certain kind of snake. Like,
Yeah. Well, so there's a fun bird story, and then I have a fun, I guess, sad story. So the snake story. So Thomas Edison was trying to like record the temperature of the coronas, like the light that went past the moon, and
I did
he
know
like
that.
set.
Okay.
Oh,
Mhm.
did you know he set himself up in a barn, and he was like trying to make these recordings, and as soon as the eclipse happened, all the chickens came into the barn to roost, and like he was inundated with chickens to the point where he couldn't take his recordings. I thought that was really funny. So
I mean, but
birds
also that
make great
sucks.
cues.
Like, imagine like designing this experiment and it's for this like rare phenomenon.
Yeah, and then like yeah, being inundated by chickens. So the first recorded eclipse was in 2137 BC in China. And apparently the story was that they have these astronomers that keep track of the sky and they look at it every night. And in particular the night or the day when the eclipse happened, they had like fell asleep, and so they didn't alert the people and like ring the bells and tell them that the eclipse was happening. And in ancient China, the story was that this dragon is coming to eat the sun, and
Oh. Uh-huh.
they would have to scare it away with like fireworks, and they were successful at scaring it away with fireworks. However, because they slept through the alarm, these astronomers are executed for being
Ooh.
I know.
Because they're
um
like, I mean, fair. Like that's like a very like that's kind of like that's kind of the modern equivalent of like the people who like are supposed to launch the nuclear missiles, like being on drugs, whatever.
like missed the cue.
Right.
um Yeah, so then they were executed for, not doing their jobs properly. Another cool story, I guess in the Middle East, like like another one where they like recorded the eclipse, or they didn't they could we could backtrack and figure out when the eclipse was like there was these two like fighting factions in the Middle East, and there was an eclipse in the middle of the fight, and then they just ceased fire and was like, yep, that's a bad omen, or that's an omen telling us to stop fighting, and they ceased. Which is kind of cool because um because we knew this fact that like this war ended on this date, and we know the location of this war. But if you like backtrack um the eclipse, like if you model it, it actually puts it in a different location than it currently is. That battle could have happened, like it would be like in the middle of the ocean, and it's actually used as evidence that Earth is slowing down, and because like the rotation of of Earth is slowing down since like this historical event. So it's kind of cool. Like, you can like mine like history of science, or you can
Yeah.
mine, yeah, you can mine like really cool information from like cultural events.
Wait,
Um
so the location shows that like the rotation of the Earth around the sun.
Yeah, so like if you took like basically if you mapped the orbit of like Earth, Sun, and like the moon, and you mapped it for that date of where that eclipse is, where the moon would have had a shadow on Earth is a different location
Oh,
than
I
it is
see.
than
Yeah.
where that battle
Yeah.
could have happened. It like was like over the middle of the ocean.
Oh
And
wow.
so you
Yeah.
could tell the shift by that model. So you have to account for the shift in the slowing of the rotation of Earth. And so that was like actually evidence, and it's like in a journal, in a paper, like properly somewhere. I thought it was really cool. Like here's like evidence for an event, uh, like or like a evidence of the Earth changing, like recorded through history. Like these people just recorded the battle. They weren't really like looking to
Mhm.
record.
They weren't doing science on eclipses. They were just like, oh,
Yeah,
this thing happened.
yeah, like not on purpose. They like we just they did they did science or we used their data as science. So I thought that was like a cool historical note. But my favorite eclipse story is the one about the eclipse in 1919. And this simultaneously proved a famous theory and disappeared a planet. Which I
Huh.
thought, yeah. So I remember reading this in like a plaque somewhere in like some museum, and I was just like,
Mhm.
no way. And then like in revisiting these stories for this stream, I like reread the story, and I was just like, oh my gosh, this is such a good story. Like why is it not more well known? Um, so many. Okay, I wrote the dates down because I'm really bad with dates. So in 1915, so I think it was like 1905, Albert Einstein wrote a journal, like wrote an article about specific relativity, and it took him 10 years to write another article about general relativity. And so that was in 1915. So this
Mhm.
is the general theory of relativity. And so the idea of this is that the fabric of space-time is warped in the vicinity of gravity, and especially in really strong things like black holes. But back then they didn't have black holes, so they're talking about like
Mhm.
the sun, basically the
I mean, but
gravity of.
like we didn't know about black holes. You mean? Yeah.
Yes, yeah, we didn't know about black holes in 1915. And back then, they also were tracking the orbits of all the different planets, and they noticed that Mercury had a really funky orbit, and their funky orbit did not follow like Newtonian laws, like and so
Mhm.
they explained it away by saying there must be another planet that's closer to the sun, like closer to the sun than Mercury is, and it must have a gravity pull that would throw off Mercury's orbit so that it has this like funky movement. And like they went so far to name this planet called Vulcan. And so this planet explained the funky orbital path of Mercury for like years. And so uh eclipses was a really good time because the sun was obscured. You could like look for Vulcan basically.
Uh,
You'd be like,
uh-huh.
where is Vulcan?
Mhm.
Like it must be there. So that was like one thing people did during the eclipse. Like astronomers were doing like but then there's this dude called Eddington. What's his first name? Arthur Eddington. I think he's like one of the OG like astrophysicists. He was like a proper mathematician and physicist. And he was just like, well, okay, so um if Einstein's theory of relativity, the general theory of relativity, is correct, then the gravity of the sun should alter the path of like light. And so his experiment was to take a picture of the star field with no sun, like during the eclipse, and to take a picture 6 months later when there were
Oh, that's cool. Yeah.
to see if the star field like shifted, right? Because
Right.
if it did shift, that means it did alter it. If it did not shift, then like that, then Edison,
Oh, that's a really cool experiment.
yeah, it's like so simple, right? He was like proposed
Yeah.
this, like he read Einstein's paper, and then he was just like, yeah, let's do this experiment. But this was like so 1915. So the next eclipse was 1916. And and the next two eclipses, 1916, 1918, had two eclipses, and he didn't do this experiment for neither of those years, because they were in the World War One. So we were humans were occupied with other things. But he did. So by 1919, when the third eclipse, since he like proposed this idea, came around, he did do the experiment, and lo and behold, the stars shifted. And they were like, oh, so in that one experiment, Vulcan, the planet, is no more. Because if you factor in the fact that the gravity of the sun can alter the change of like light, it can also alter the path of Mercury. And therefore, instead of a smaller planet or a small planet that's closer to the sun that altered the trajectory of Mercury, it was actually just the theory of relativity working.
Oh, wow.
And so it both proved Einstein's general theory of relativity and also killed the planet. I thought that was a really cool story.
So they didn't directly look for Vulcan during the eclipse. It was just they were like, okay.
Yeah, no, so they've been looking for Vulcan like before 1915. Like every time there's an eclipse, they'll look at it and they could not find it. They're like, where is this planet? And they're like,
But
oh,
then I guess it could be like it was always like on the other side. So like that doesn't
correct.
rule it out. Yeah. Yeah.
Yeah, so they couldn't rule it out, but then they could never see it either. So it ended up being true that it just didn't exist. Yeah, I don't know. I thought it was a really cool story.
Yeah,
I was like,
but that's a very cool like it's such an elegant experiment. Like it's like, okay, yeah,
here's this
it's
picture.
like let's see if it's like if this light is distorted when the sun's there, and then we use
Like
out the light
space
from the
time,
sun.
it'll
Yeah.
curve light. Like it was really nice. Anyway, I thought that's my eclipse story for this year.
I was gonna mention. So we were talking like I feel like it's interesting. So you were talking about like like oh it's so weird they actually thought there was like this extra planet, right? And like one thing I was reading about is that actually this is still kind of a topic of debate is how many planets there are. And like not just because like things that like not just because there's this debate about what should be classified as a planet, which there is, but when you get to the very far edges of the solar system, it turns out that an object like that's about the size of Neptune, which is like a couple times bigger than the Earth, would actually be very difficult to observe directly, just because the light out there is very weak, it's very far away. It would just like we don't have telescopes that can do that easily. So actually there's people who have been proposed that there's another quite large planet beyond Neptune's orbit that is like a couple times the mass of the Earth. And the reason they think that is because there's this group of basically comets and asteroids that seems like they're weirdly grouped together, like they kind of got caught in something's gravity field and pulled together. And so one of the theories about that is it's called Planet Nine, and one of the theories about it is that there's this other big dark planet out there that we can't observe.
Oh, I did not know that. That is cool.
And I will say, so kind of this theory's been around for a while, and there have actually been a couple of surveys, like sky surveys, where their goal, like, well, it wasn't their goal, but basically it kind of put limitations on this planet, because it's like with these instruments, if it was above a certain size, they would have detected it, and they didn't. So there's also some skepticism about like, okay, is there really a planet? Like, is there a planet out there, or is there just some other physical property that explains why these asteroids are clustered together? Kind of very similar to the Mercury thing, actually.
Yeah, okay,
Um,
so this way of thinking about, stuff in space is not
Yeah.
new. Like
And
they
actually,
still do it today. It's not
yeah,
like really off the mark, right? Like it's not like wrong. I
right.
mean, they were wrong, but like it's not like a
Mhm.
bad way to think about,
Yeah, and I think this is
why certain things are there.
yeah, I think this is an interesting thing about a lot of space sciences is that like you're dealing with things where like you can't really manipulate it, and oftentimes you're trying to study phenomena that you can't observe directly. So you kind of have to come up with these weird, clever ways of doing it, like being like, okay, we think there might be a thing here because of how it's or like because of how it's like affected the orbit of this other thing.
And you have to like infer from
Yep.
that. No, that's cool. Didn't know that.
Yeah.
Um,
I feel like it's
interesting.
quite similar to like cognitive neuroscience, actually. And then it's like we study things like intelligence, and it's like, okay, we can't actually measure that directly, but like we can like study it indirectly.
That's true. I never thought about it that way either. Yeah, we kind of measure like blood flow, right?
Yeah,
Or
or even just like it's like, okay, you want to like measure, like you want to kind of know like, okay, what genes predict like how much working memory someone has. But working memory isn't like, it's not a physiological quality that you can go in and measure. So you have to have tests that are like sensitive to working memory, and then you have to like compensate for other things that might affect the tests. And it's very similar to like what astrophysicists are doing.
yeah. Just marking out my holes.
Pringles. Yeah.
Pringles. Yeah. Okay. So the idea of this projector is that I made a screen. I basically in the cap cut a circle from this
Mhm.
envelope, and I just put a little bit of cardboard in the cap, just to like darken it. I might swap this out for aluminum. So this is the projection screen.
Mhm.
Basically, this is what I would be looking at when during the eclipse. And right now, and this will go here, and then I would put a pin in the bottom of this can, just like punch a hole here, and then I would look through this like side hole. And so basically, during the eclipse, instead of looking towards the sun, I will be looking down and into this device, like facing away, like from the sun.
Why do you look through the side hole instead of just like projecting it onto like a translucent thing and then looking at that?
Yeah, so you can, well, you want to, so it's a you want to like a dark space, I suppose. So the other
Oh,
one,
I see. Yeah.
yeah, so the other one I want to make is I want to make it in this bottom left, like the hole in the bottom left corner for my right eye, and then pinhole in the top left or top right corner. So
Oh, I
like my eye
see.
would be
Yeah.
here, and then
Yeah.
this would be where the pinhole would be, and then that way I could just like look straight. But
So
for
this is
Pringles,
gonna be your better effects camera.
correct. So it will also be holding my my gloves. It's my glove box. So as I travel with, but I thought I would start with the Pringles can, especially like since I will likely be very excited and like wanting friends to enjoy it with me, and you can't really share. You cannot. I'm so this some lucky friend will just get to use this one. So currently doing the most dangerous part of this exercise, which is cutting hole with razor knife with razor blade. So if I seem distracted, it's because I don't want to hurt myself.
You don't want to
But
cut
you,
yourself. Yeah.
yeah, but you had a bunch of topics you want to talk about today too, right?
Oh yeah.
Besides
Yeah.
aliens.
So I was gonna so also so because we're talking about kind of stuff that happened. So the eclipse is happening really soon on Saturday. But I wanted to talk about something that happened recently, which was that NASA got a sample of an asteroid, and they actually have a space probe that captured a sample of the asteroid and brought it back to Earth, which was pretty cool. It's
That is super
also, I mean, okay, so did you ever read the book The Andromeda Strain?
No, you told me to read this book, and
Yeah.
it's on my to-read list. I couldn't find an
Okay.
audiobook of it, but I will
Oh,
get around to
sad.
it. And
Anyway, the Andromeda Strain is about what happens when scientists send up this experiment into orbit, and it captures interstellar dust, and then it comes back, and it turns out the dust is infectious and like kills a lot of people. Anyway, my point was this experiment actually reminds me like of the Andromeda Strain a lot, but that's besides the point. But what this is called is that's not what we wanted.
Drost
Yes.
effect.
1 second. Let me pull it up. So the space probe that did this is called OSIRIS-REx, and it was launched in 2016.
Does it have? How does it capture it? Does it have like a net?
Oh, okay.
Like,
That's like actually I was gonna say that was like I think one of the coolest parts of this. So I'll pull up the picture of it capturing it. Yeah. And so kind of the so what it does is this is the space probe right here, and actually like the space probe basically went to this asteroid, it went into orbit around it, and then it just slows itself down to a very low speed, and then it literally just kind of goes down to the surface and touches that thing to the surface and sucks up some of the asteroid and then leaves. And this is so this is actually like I mean and like in some ways that seems like the logical way to like get a piece of an asteroid, but it's also like pretty weird. So kind of traditionally how NASA has done this in the past, or how other groups have done this in the past, is that like there was a mission that went to a comet, and basically they just flew a thing through the comet tail, and they tried to just scoop up the like comet dust out of space. Another approach has been like you basically kind of fire a bullet into the thing and then again scoop up the dust. And like those are easy because then the dust just kind of goes where your spacecraft is. So this one is actually super weird because the whole spacecraft has to slow itself down and approach the asteroid and then just like extend this arm. And like there's all sorts of weird things it has to do. So you can see like in this picture, it has its solar panels kind of making a V, and so it has to kind of fold its solar panels up as it gets near to the asteroid so they don't get dust on them.
but so it has to match the speed of the asteroid.
Yeah,
Like
let me
precisely match the speed of a flying object in space.
Yeah, and I mean, so I will say so it and that's made easier by the fact that they actually put it into an orbit around the asteroid. So kind of once it's in the orbit, it's kind of mass matching the speed passively because the asteroid is just kind of dragging it along in its gravitational field. But then and then what they basically do is they kind of change the shape of the orbit so that it just kind of very slowly skims by the surface of the asteroid, and then they can extend the sample. So this is called the touch and go sample acquisition mechanism, or TAG-SAM.
Okay, TAG-SAM sounds way cooler than touch and go, because touch and go sounds like it might not happen.
I mean, which I think they also thought, honestly, but like
they're like, this may or may not happen. Let's just call it the touch
right.
and go system.
Yeah. And actually, so sample acquisition. Oh yeah, so they mentioned they move the solar panels, and then they slowly descend towards it, and then it actually touches the surface. They then like squirt some nitrogen at it to basically like help blow the particles into the collector, and then it takes off again. And actually, so you're saying like it sounds like it might not work, and actually they thought it might not work. So kind of in this mission, like after it like acquired the sample, there was a contingency in place where like if they weren't able to pick up enough stuff, it could actually go back and try again. But like it actually worked surprisingly well. Like it picked up more asteroid dirt than they thought it was going to, and it actually kind of jammed the sample collection thing open.
Oh no.
I mean, but like apparently it worked okay. So they like so it had to it so like kind of initially like the container didn't seal properly because there was too much stuff in it, but then I guess the excess stuff escaped and they were able to seal it. And then the other really cool thing about this mission is that they then dropped this thing like back off on Earth just like a couple of weeks ago. Yeah, on September 24th. And so basically they just fired it. It broke out of orbit with the asteroid. It started drifting back towards Earth. It got captured by Earth, and then it ejects this sample return capsule, which then re-enters. It landed in the desert, and NASA picked it up and are now looking at the sample.
Oh wow, that's so cool. Like they didn't even like it's still in orbit. Like
yeah. I think
like
yeah.
That's very cool. Which means it can go out again, right?
Oh, interesting. So it actually says here the main spacecraft maneuvered to a trajectory away from Earth for its extended mission to Apophis. So it's going to go look at a different asteroid, I guess.
Wow.
So that's cool. Yeah.
Yeah, I like this like recycling situation where they're like reusing like the mission is not just like one thing. It's like we have a backup, we have like a plan B mission. Like we have a mission after, do you know what I mean? Like
yeah. It is kind of a crazy mission because like just like the trajectory that this thing took, like it's like it launched away from Earth. It did like a gravity assist to basically give it more speed. Then it went into orbit around this asteroid. It like landed on the asteroid basically, then went back to Earth, and then like goes to a different asteroid.
Yeah, like that's pretty cool.
Yeah. Anyway, yeah, so that is another cool thing that happened.
That is a really cool thing that happened.
Yeah, what else? Oh yeah. Oh, also I wanted to talk about so also kind of just like on the topic of just like weird stuff that is out in space. One thing that I was learning about was that kind of also related to the like this, if there are other planets like out there. So we don't know about that, but kind of I was reading about, it's called the Kuiper belt or Kuiper belt. And this is basically out where Pluto is. And in fact, so Pluto is considered just like one of the objects in this Kuiper belt, and I'm trying to pull up the image of it. So one of the reasons that Pluto isn't considered a planet anymore is because we kind of discovered this thing. We kind of discovered that like there were all these objects that were out past the orbit of Neptune, and again, it was kind of, we didn't have the ability to image them until recently, but we discovered them, and then we were like, okay, if we're going to consider Pluto a planet, like there's all these other things that are also would have to be planets. So the Kuiper belt is in green here, just for reference.
Wow.
So you can see, and each of these I think is an object in it.
That's a lot of objects. That's way more than I thought there would be.
Yeah, there's a ton, and like most of them are quite small. Like they're sort of Pluto sized or smaller. A lot of them are much smaller. And most of them are basically just kind of chunks of ice, so they're kind of boring. But like it turns out there's like basically all these random dwarf planets out there that like we didn't learn about it in school. Like there's um like did you know that there's this like dwarf planet called Ceres, which is out there?
I knew that there was like 4 dwarf planets. I didn't realize that there
Mhm.
would be that many. Like that image you just showed me, that is like way
Mhm.
more than 4. Like
Yeah.
4
I
things out
mean,
there.
okay, and in fairness, like most of those Kuiper belt objects are like very small. Um, like it, like they're not even dwarf planets. They're just like this is just like a chunk. Like they're just like house-sized chunks of ice, basically. But there's
Yeah.
a there's just like there's a ton of stuff out there in the Kuiper belt that we don't think about, which I just
Or
thought,
we were just not taught in school because
yeah,
we didn't
and then
know.
don't think about. Yeah.
Yeah.
But no, like actually when I was thinking about this, I was like, this would be a really good premise for like a sci-fi book or show or something. Because like there actually are so many just like random bodies that are in our solar system that you could use, right?
Yeah. Oh, that's really cool.
Yeah. And then also, so there's the Kuiper belt, and then there's also this hypothetical thing um, out there called the Oort cloud.
The Oort cloud?
Yeah, I'm not sure if I'm pronouncing it correctly. It's like Oort. Um,
That sounds accurate. Or Oort.
Oort. Yeah, yeah. I
Yeah,
don't know,
I think
but
you're right.
anyway, this thing is also considered a part of the solar system because it is like they're technically in orbit around the sun, and it's basically a ton of extremely small objects. So kind of in this diagram, kind of the Kuiper belt is kind of out a little bit past where Neptune is. um, the units here are astronomical units, so it's the distance from the Earth to the Sun, and it's on a log scale. So kind of it gets bigger the further out you go, or kind of it gets more compressed the further out you go. And so it turns out this Oort cloud is really far out, and it's just like it's absolutely enormous, like both in terms of like the number of objects and just like its physical size. And you can see it actually extends like pretty much into what we would consider like interstellar space.
Is this
Um,
is this what makes us milky?
what makes us milky?
Yeah, like when they're like when you look in the sky, like Milky Way kind of milky. Like where it's like not objects, it's just like this kind of like
Oh,
haze. I don't know how far is it? Like do we need a special telescope to see it, or is it only we can only know about it because of these probes?
so that's the thing is that no one like this is so far out that no one actually knows if it exists.
Oh, okay. This is a
So kind
theoretical
of so the
cloud.
reason like this is which like I think is kind of crazy is so just like it's so far away that we have actually no ability to even tell if it's there or not. But so the reason we think it's there is that first of all, it's kind of predicted from our models of how like kind of solar systems form. And second, there's these long period comets, which are comets that show up like every like 100 years or so, and like hundreds of thousands of years actually. And so the idea is that and the quite like so the like so the idea is like okay, if you have these long period comets, so the a comet has a long period, which means that like it has just like a very large orbit. Like that's the only way that you can get a comet that shows up like every 1,000 years or so. And
Yeah.
so the idea is that like okay, so there must be a big cloud of these just kind of random objects that are floating out there like a few thousand times the distance from the Earth to the sun. They're floating out there. Occasionally some of them get knocked out and become long period comets.
Oh wait, so the dust of the comet, like the tail part, is what this cloud they think this cloud is made of?
No, like the comet is like what the cloud is. Like the cloud
Uh,
is basically made up of comets that are not comets because they're just kind of chilling out there in orbit and not getting heated by the sun. And then the thought is that kind of basically gravitational interactions will occasionally change one's orbit enough that it actually comes into the inner solar system, and that's when it becomes a comet.
That
So
makes sense.
basically, the theory is that comets, or specifically long period comets, are these Oort cloud objects that are just got knocked out and got roasted as they got closer to the sun.
That's really cool. I mean,
Mhm.
I love that like they come up with these like explanations for why there are these natural phenomenon.
Yeah.
And then it's like, here you go, here's the explanation for why. It's great.
Mhm.
Astrophysics is great.
Yeah.
Astronomy
Anyway,
is
I
awesome.
just thought it's a cool theory, right? Like it's like
Yeah.
it's like people are just like, oh, why are there comets? And then
And then cut to this like whole explanation.
yeah, and it's like I don't know. I really like the theories that are just like this very simple but profound observation. Like they're like, okay, the comets have to be coming from somewhere, and because of like the laws of how orbits work, like they must have been coming from somewhere really far away, because that's the only way that you could get something with an orbit like that. So
That's really cool. Um
how's
my
how's your camera going? Yeah.
I think my camera's done. I added a signed piece. So I noticed that whenever I use these, I always like use my hand to cup it. And I
Mhm.
decided that I would make one with the gaffer's tape. Some
Oh,
cardboard.
nice. Yeah.
And then that way I don't have to like constantly cup this eye
Right. You
hole.
can.
I could just
But
use
then
my
you're
eyes.
you're still like cupping around the tape though.
I don't have to cup around the tape. I could technically not need to. It is nicer without it though.
Mhm.
And
Nice.
it does need the aluminum, by the way.
Yeah.
I was trying to see if I could do it without the aluminum. But you really do. Like the light, there's a little bit of escaped light from the edges of the hole.
Yeah.
You
Yeah.
need aluminum. Aluminum is your friend when you're trying to do something light, tight.
Because that's what I was asking about, or it was related to what I was asking about before, is like, why do you need this side hole and you can't just like project it onto like a thing at the other end? And so it's because the projection is kind of dim compared to the ambient light.
Yeah, it needs to be like a little dark, like a
Mhm.
dark box. Kind of like
Could you hold it up to the camera and like demonstrate how it works, or will that not
okay,
work?
yeah, so there's a pinhole here, which you
Mhm.
can probably not see. And basically, like if that was the sun, which is the light on my ceiling. Can you see that light on my ceiling?
Mhm.
But anyway, light in the ceiling. So that's the sun with the moon going around it. And so basically, I just point this pinhole at it, and then I'll look into this hole, into the side.
And you'll see it
I'll look. Yeah,
projected
so
on
I'll look into here, and then it'll be projected onto this wall where there's a white
Nice.
piece of paper. That's my projection screen, and then I basically put a piece of paper into the cap, and then I just aluminum foil so that this bottom is nice and light tight. I don't. Is there a word for that? Like watertight, but like light, like
I
no
feel like
less
light tight,
photons.
that works.
Yeah, like the least amount of light contamination is the goal. So yeah, that is one pinhole camera done.
Nice.
Yeah,
Maybe
so
we'll
I'm
make
ready
this
for
work sooner
Saturday.
or later. Yeah.
And also in April, there's going to be a full one that goes across, like I think the east coast of the USA. So if you are in the East Coast, I'm sure I will be dragging you, Nate, to and making us build these again, for all of the people.
At first, I was not sure like who that was addressed to. Like, I'm just like, wait, are you gonna drag like random viewers?
Random viewers on
Yeah.
the internet. I will remind people, I guess, the week before the April one, so that people can prepare.
Yeah.
I don't know. It's
I'm
like
just like, there's a genre of videos on like TikTok where people are like, come with me to do activity. So like, we could do that. Like, come with me to
come,
watch my
come with
clips.
me. Yeah,
Yeah.
we could
Uh,
do that. Yeah. I mean, it's a very like I don't know. It's nice to like observe what's happening around you
mhm.
once in a while.
When you like look at stars, does it still make you feel like existentially weird? Or
A little bit, a little bit.
yeah.
I enjoy it. It's part of like
Mhm.
camping culture for me, but like I
Yeah.
don't
Oh
do
yeah,
it.
I enjoy it. Like I enjoy the existentialness of it.
The existentialness of it is good.
Yeah, no, like I feel like I would like go on family camping trips and we'd be like, oh, let's go look at the stars. And then I'd be like, isn't it weird to think about how like statistically speaking, there's probably some other organisms doing this? And then like my family would be like, Nathan, stop talking about this and let us enjoy the stars.
It's because they don't want to think about it. It's an
Right.
uncomfortable topic.
Yeah. Yeah. But like, I don't know. I enjoy that part. Like it's
Yeah, that's cool. We're probably not alone in the world.
mhm.
Um, yeah, and also this is a safe way to do it. I feel like this is actually the safest way. I don't know how much you trust those like eclipse glasses or
Eclipse
whatever.
glasses. Yeah.
Yeah, I don't feel like they're. I mean, they might be very safe, and like doctors probably say fine, but this, just don't look at it. Like, do not look at the sun. Just don't look at the sun. Like PSA, do not look at the sun. It is bad. Build a projection machine, and like, it's. I mean, it's the cost of a Pringles can or a shoe box, or in my case, a glove box.
hmm
Like, it's a very cheap activity. Highly recommend. Um, and like, don't be too sad if you missed Eclipse this time. It comes back like every couple of years. It's like I feel like the media makes it sound like it's a super rare event where it's like it won't be here until 2034 ever again. Like you must catch it. And I'm like, well, like it'll be like a state over like in like 2 years. Like get in a car.
hmm
Or
Like if you
um
want to see an eclipse, you can. Is what you're saying.
yeah, that's true. It's like don't be like super sad if you missed it. And like, FOMO. Um it's okay. It's okay if you miss it. There'll be another one. If you missed the one this Saturday, there's gonna be another one in the spring in April. And if you missed that one, there's literally a camera, a list on the internet where they tell you like the path of the moon. Oh, what's also kind of cool while I was looking at these maps of the path of lunar eclipses is that at different parts of like different latitudes the amount of time the moon you're in full eclipse mode is different. So because the earth is rotating at the same time the moon is traveling, basically when you're closer to the equator you can get longer eclipses, like 7.5 minute
Huh.
long eclipses.
Because
And if
you're traveling faster.
yeah, because the Earth is traveling, so it can catch up with the shadow. So basically, the shadow is like flying across the surface of the planet, but it flies slower in comparison when near the equator. It's still going like 800 miles per hour or something like that. Or no, yeah, is that right? Yeah. I think you have to be like in a jet plane to like chase it. Like there's some like aficionados that are like eclipse people. Like they pay for like jets to like chase that shadow, and they like are
Oh
in
well,
the
so they can
eclipse for
like
like
stay in it for a long time.
in the shadow for like 4 hours. And I'm just like, isn't that just like nighttime? Like
I don't
it's
know,
just
like
dark.
like that sounds like it could be a fun party. Like you like charter a plane and then you just like go in the eclipse shadow and like drink.
That's true.
Yeah,
Okay, so
like I would do it if
and
I had a lot of money. Um,
okay, so the 14th is an annular one. There's a partial one at the end of October, so October
mhm.
28th, 29th. There's a solar eclipse on April 8th. So that's the next full one. And then another one, another annular in October 2nd of next year. So there's like two full eclipses. Well, a total eclipse and an annular. An annular is kind of different. It's a donut one, right? It's the one where you can see the ring of
Mhm.
fire. Um, yeah, pretty, pretty,
Yeah.
pretty cool things in the sky soon. I don't know if you missed it, but the moon and Venus were really close to each other this past week too. They were like
Oh, yeah.
both on the horizon. Um, I got really lucky. I got clear skies for that, but I might not get as lucky tomorrow because I think it's gonna rain. So
Oh,
I'm
sad.
gonna be obscured. Yeah, but I think the shadows are still weird even if it's raining.
Yeah,
Um,
even if you can't see it directly. Yeah.
yeah, which is why I'm like projections look way cooler because
Mhm.
you can still get a cool shadow when even if you can't see the sun with your whatever the the super sunglasses that are darker. Anyway,
I was going to mention one last space phenomenon that has been happening, which is, did you know that we are currently in the solar maximum, and also that this is a thing. So it turns out that the sun has an 11-year cycle of how bright it is. Um, and also how many sunspots there are. So it actually the biggest variation is in the number of sunspots and in the number of solar storms, where kind of like it injects charged particles at the Earth. And for some reason that I don't remember, that I'm looking up now to see if anyone actually knows why it happens. Oh yeah, I think that I looked this up. No one is quite sure why it happens, but there's this 11-year cycle in terms of the number of sunspots, and kind of the theory is that it has something to do with like the sun basically has this big kind of convection of heat going on, and it's kind of turbulent, and the idea is that it's this kind of chaotic system and interactions and that produce this 11-year cycle. But anyway,
does that mean does that mean our magnetic field is being like really crazy, and is that why we're
yes.
seeing a bunch of auroras? Okay.
Yep. Yeah. So that's the effect on us, is that it, because the sun is ejecting more of these particles at us, we get more auroras, because the auroras are caused by the particles basically being deflected by the Earth's magnetic field and entering the atmosphere at the poles. Yeah, so this is how it's usually quantified, as the number of sunspots on the sun. So no, I don't want these dudes.
I did not know that was the
Yeah,
physics of the sunspots on the sun.
yeah. Just in case anyone is not. Oh yeah. Here's a good picture. So these sunspots. So this was images taken of the sun at different times, and you can see how kind of it goes from very spotty to not very spotty, and then spots kind of reappear again, and that's over the whole 11-year cycle. Anyway, so we're currently at the peak of it, which has some really interesting effects. It means we get good auroras. It means that the atmosphere actually gets slightly larger, because this increased radiation from the sun actually kind of just reduces the density of the upper atmosphere and makes it expand, which is actually a big deal if you have satellites, because it puts more drag on the satellites, so their orbits decay faster. So it makes the atmosphere bigger. It means there's more solar storms, which are when just there's a big burst of particles. It can interfere with anything that's sensitive to radiation, and can, in rare cases, can even kind of create like an electromagnetic pulse that damages electronics.
Oh, that's cool.
Yeah.
I really wish
Anyway,
I looked for auroras more this past
I feel like there
couple
haven't, like,
months.
none have made it down to like where you are though. Like,
Yeah, they're not all the way down here. And when I was in Iceland, a couple like last month, there was still too much sunlight. Like
oh, it's bad.
there's too much daylight. It was like 17 hours of daylight a day, so like there wasn't enough like dark time.
Because you have to go to Iceland in the winter for auroras, right? Or else
Yeah.
it's like it's too
But
light. Yeah.
hopefully, I mean, hopefully New England sometimes gets auroras if there's a really bad solar storm, or a really good solar storm, you get some nice auroras. So
Nice auroras. Yeah.
yeah, goals. I still have yet to see like proper auroras.
Me too. Yeah.
Yeah. So on the to do list.
It's like, I feel like the problem for me is like, whenever there's been a good solar storm, like just by coincidence, there's always been like a normal storm also. So like you can't see the aurora, just because there's
Yeah.
clouds.
There's like
But
clouds.
Mhm.
Yeah, it is very. You have to. It has to be like good timing. I feel like I thought about this recently. I was like, I think astronomers or like are also probably really good meteorologists. Like they just really pay attention to
Mhm.
the weather because they gotta know where to be to like see the best thing. Do you know what I mean? Like, um, because like it's very possible to be like, hey, there's just like really cool phenomena happening, and it's like, oh wait, also it's gonna be foggy, or oh, it's gonna be overcast. Like a
Mhm.
cloud in the sky, like could ruin
Yeah.
um their
And that's a big
observations.
reason why a lot of the newer like optical telescopes that we've built are built at super high altitudes. So there's like they'll be like at the top of Mauna Kea in Hawaii, which is like 14,000 feet. And the reason is like literally just because that puts you above most of where most of the lows like weather phenomena will be.
Yeah, and there's like no storms. There's like there won't be a
Yeah,
storm.
yeah.
Like you'll be good.
It's like there's no clouds, and also the atmosphere is very dry, which I guess like even if there aren't clouds, just having any like just having humidity in the air just distorts the image you're getting a little bit. So you get the clearest image if you're like on a mountain somewhere very dry.
That makes sense.
Mhm.
Kind of cool to do science in Hawaii.
Mhm.
um,
Apparently, some of them like the telescopes are so high up that people kind of start having cognitive problems when they're working there because they're of the altitude.
oh, like altitude sickness.
Yep.
Um, I imagine it was probably kind of lonely too, because it's like
Mhm.
I'm imagining not a lot of people are living on the top of this mountain. Like, they're
Yeah,
probably
probably
at
not.
like the majority of people living in Hawaii are at sea level.
Mhm.
Like, they're not on the top of this mountain. So like you like, you get to visit the people, but then you gotta like trek up to this top of this mountain, and then you're also like nocturnal because you're
Are
up at
doing
night.
stuff at night. Yeah.
Yeah, you're doing like yeah, because your job is at night.
Mhm.
Um, very cool. Oh, I just realized that all astronomers are nocturnal. Maybe we
Yeah.
should make astronomer friends. Our schedules would match.
You should do it. Like go over to the like Harvard astrophysics or whatever and just be like, hello.
Hi, we have the same schedule. Want to hang out? They're
Yeah.
like, we're working. Stop talking.
That's true.
To be fair, I'm up not doing work usually.
That's true. Like you're like working in the evening, but then like at night you're just hanging out. So it's like we
Yeah.
can go bother the astronomers.
Yeah, let's see what they're up to. Is there something cool
Mhm.
going on? I did
We're
look
just
up
like, hey, what are you?
what you looking at? What's
We're
that?
just like, why are these neuroscientists here? Like, go home.
They always here. Yeah. Yeah. I looked up I got well, basically I've been getting all these emails from MIT, and one of them was
Mhm.
like bike routes, like to cool science like locations. And I was like, yes, I want to go. And one of them is like a like an astronomy tower that's like north of Boston, about like an hour bike
Ooh.
ride. Yeah. I was like, yeah,
MIT like suggested it to you or?
yeah, like it was part
Oh
of
yeah.
the
Mhm.
bike. I am at the phase where I still read the emails. It's gonna quickly
Mhm.
end, but like right now, I am reading
Yeah.
all the spam emails, the ones that are like, free food on this floor.
Mhm.
But this one was like a bike to
Like
cool
bike
science
info.
site. Yeah, yeah, yeah. They were
Yeah.
trying to like advertise, um, just like bike, like creating sites or elevating some science sites into more mainstream tourism
Oh nice.
kind
Uh-huh.
of kind of thing.
Mhm.
Let me see if I can find uh bicycle. Um but anyway, oh, it just hit 10. So thank you for joining us. We didn't have a lot of humans today, but that's okay. I learned a lot of cool things.
Mhm.
Um
Yeah.
and I got to tell someone
You got to make a telescope.
I did.
Or not a telescope, a camera. Yeah.
My projecting my little projector thing, and I got to tell my interesting story to someone because
Mhm.
I was just bursting with it. Um, Yeah.
Yeah, I got
And
some real
also,
interesting facts. So yeah.
yeah. And this is
Cool.
the last time I will be streaming from here.
Oh yeah, nice. Then you're moving. Yeah. Okay. Well,
Yep.
yeah. So we will see you next week for a show. I don't think we've decided what we're gonna do.
Nope.
Yeah.
But it'll be interesting. Thank you for
Yeah.
joining us.
Great. Thanks.
Goodbye. Have a good night.